Calculus students, hello. This is chapter 4.5. Continue with concavity test and first derivative test. So another example. So we did one example in part 3, which is very difficult. So I have two more that I want to went over, and then one last part of, which is the second derivative test. This takes really long because basically you will have to do, just write a line in the middle. Oops. And you have to do a first derivative test to find out the increasing, decreasing, right? And then you have to do a second derivative, no, you have to do a concavity test, not second. First derivative test, second derivative, no, concavity test, not second, because I was thinking I'm going to teach it. Concavity test to find concave up and down, first derivative test to find increasing, decreasing, and also local max and mean. So let's do this one. So we do the first derivative. F prime of x is equal to, it is chain rule, 2 over 3, 5x plus 30 to the power negative 1/3, right? Because 2/3 minus 1 is negative 1/3. That means it's 2/3. It's a root in the denominator, 5 plus 30. But it's a cube root, right? So this is what the derivative is. So if I solve this to 0, there's no 0 because the top is 2, right? And the denominator is undefined. Undefined at what? Undefined c is at c equal to, or at x equal to 5x. I forgot the x. When 5x, undefined at when 5c plus 30 equal to 0. That means c equal to negative 6. So I'm going to do the number line of negative 6. That's good, only have one. And then plug into here to do a negative 6, lower than negative 6, so x equal to negative 7. You plug in negative 7 is a negative, so the whole thing is negative. If you have x equal to, can you do 0? Yeah, you can do 0 on this side. 0 will be a positive, the whole thing is positive, right? So you have increasing on this side, decreasing on the left hand side. So increasing from negative 6 to infinity, decreasing from negative infinity to negative 6. And what about this point? This point is the minimum, right? Local mean is at negative 6. Comma what? So if I plug back into the original one, if I plug in negative 6 is 0, right? Because negative 6 is just 0. So remember when you do the local mean, this is f of x. So this is increasing, decreasing, decreasing, and also local max and mean. There's only a local mean. What about concavity test? Concavity test is to do f double prime. So I'll look at the first derivative, which is this one, and I'll do one more, right? One more derivative. So I have 2 over 3 times negative 1/3 now, because it was negative 1/3. Negative 2 over 9, and then 5x plus 30, negative 4 over 3. Okay, negative 4 over 3. So it would have a negative coefficient, and then in the denominator is 5x plus 30 to the 4th power, and then you do a cube root. So do you notice that it's the 4th power and the do cube root? This is always positive, right? This is always positive. So what is the undefined number? Undefined at, again, at c equal to negative 6. So we do the same thing again, still negative 6, but we plug in here. And when I plug it in, this is always positive, right? If I plug in x equal to negative 7, this is a negative number, but when I 4th power it, it's positive. So multiply with negative 2 over 9 is negative. And then when I plug in x equal to 0, again, this is positive here, and it's still negative. So they're both concave, what? Down on both sides. So we say concave down from negative infinity to negative 6 and negative 6 to infinity. There's no point of inflection, no concave up. Okay, so that's how I do that one question. The second question, let's finish it. So again, put in the middle, first derivative test is for increasing, decreasing, and log derivative. So f prime of x, so it's an x fig and g, right? Fig, f, and g. So f prime is 1. So 6x plus 1 square. What power? Okay, a fig first. Derivative of x minus 1 is 1. 1 times 6x plus 1. And then I minus what? 6x plus 1, derivative of this times, so the 6 times x minus 2. So it turns out that the x and 6x and 6x cancel. I have 1 plus 2, no, 1 plus what? 1 plus 12 is 13. 13, 6x plus 1 cube. Oh no, square. So there is no solution, no equal to 0. 0, then is no solution. But there is an undefined number at what? X equal to negative 1/3. So C is negative 1, not 1/3, 1/6 for undefined, right? Undefined for this. But 6 equal to negative 1/6 is also actually a number that's undefined. So let's figure out what it is. When I plug it in, f prime is always positive. For x is equal to negative, negative 1. When x is equal to 1, still positive because your denominator is square. So it's always increasing. So you would say increasing at what? Negative infinity to negative 1/6, and then at negative 1/6 to infinity union. No decreasing, no local max or local mean. And then concavity test. Concavity test, which is the second derivative. So this is the first derivative. I'm going to do the second derivative. That means f double prime of x is equal to what? Negative 2. So it's negative 26 over 6x plus 1 3 times, because it was negative 2 minus 1 is 3 times. So negative, so when I do the undefined number, so it's just negative 1/6 again, right? Because it's undefined. There's no 0, but critical number, critical point is negative 1/6 because when the thing is undefined. So testing x equal to negative 1. If I do negative 1, I have negative in the denominator and negative in the numerator, so that's positive. When I have x equal to, let's say, 0, I have positive and a negative, so this is negative. Concave up, concave down. Oh, I do have an IP. Okay. So I would say concave up at negative infinity to negative 1/6. Concave down at negative 1/6 to infinity. What is the point of inflection? No point of inflection. Why? Because negative 1/6 is not defined. It's just a critical number. But when you plug in the original things, it's not defined. So although there is a change of concavity, it's not. What happened is this is actually an asymptote. So close to the asymptote, you imagine that it is something like concave up, right? Like that, and then concave down. That's why it's always increasing, but and concave up and concave down. Okay, the last part is second derivative test. Okay, so don't confuse this with concavity test. Although we use second derivative, but has nothing to do with concavity. It's not testing for concavity. It's used to determine whether a critical number is a local max or mean, which we can use. So it is an alternative for first derivative test. Because in first derivative test, we actually can determine local max and mean, right? But you know how we have to do a lot of testing and draw the number line. It's just kind of difficult. So this second derivative test use the fact that when you get a second derivative, and if your critical point is actually like when we have these number line things, and when we are testing for the first derivative, like here, no, this is just still concavity. Right, this ones, you see how we have up and down, these things increasing, decreasing. So when it is when it is a low, a maximum or a local minimum, it is changing, and they actually have concavity. So they use the fact that if it is a maximum, a local maximum, it is always concave down for max, right? Local max. And if it is a local minimum, the curve around here is concave up. Okay, concave up for local minimum, concave down for local maximum. So instead of doing test point, they say just plug into the second derivative to see if it is positive or negative, because they would check your concavity. And after you check it, you don't have to do any testing. So it's an alternative of first derivative test. So that's why it's called second derivative test. It's kind of like it's using second derivative, and it's the second choice of finding local max and mean. So just do one example. So someone has a function x to the fourth minus 4x cubed plus 2, and someone has actually find a critical number c equal to 0 and c equal to 3. So usually we would just say, oh, you have the critical number, I'm just going to do those plus, plus, plus. No. We would just use the second derivative to determine if these are local max and min. So do not draw the number line for 0 and 3. Just do it. So do the second derivative. Well, do the first, right? First derivative of x is equal to 4x cubed minus 12x squared. Second derivative is 12x squared minus 24x. That's it. And so we would test second derivative is just doing things. Put the critical number 0 here. And it's equal to, if you do 12 times 0 square minus 24 0, it's still 0. So it's neither local max or mean. It could be just a point of inflection or something. But what about f double prime of 3? If I put in 12 and then 3 square minus 24 times 3. So this would be 9 times 12 is 90 something, right? 9 times 12 minus 24 times 3. I think it's positive. So it is positive. Positive is concave up. Concave up means this is a local mean, because it's here. So local mean 3 comma what? 3 comma the original one. So 3 to the fourth minus 4 times 3 to the third, 27 plus 2. Oh gosh. 3 to the 4. 3 to the 4 is 81. Let me just do 81 minus 4 times 27 plus 2. The original equation is negative 25. So the local minimum is 3 comma negative 25. We can actually kind of confirm that 4x4 minus 4x cubed plus 2. Oh, is it 4? No, x to the 4. Go to decimal. X to the 4th minus 4x cubed plus 2. So we have a 0. 0 is not a local max or mean, but you can see that this is a local mean. Okay, 3, negative 25. So that's the use of second derivative test. No need for testing. Just plug in the second derivative. Okay. Um,